Good morning, all. So, in portfolio construction, we are dealing with the problems of Markowitz model with three securities. So, let's look into the problem. Stock R and S displays the following returns over the past 2 years. Here, year is given, return on stock R and return on stock S. So information about two stocks R and S are given for 2 years. So that is 2013 and 2014. So in 2013, return on stock R is 10% and on stock yes, it is 12%. Again 2014, return on stock R is 16% and on stock S it is 18%. Here, the question asked is, what is the expected return on a portfolio consisting of 40% R and 60% S? This is the first question. Then second one is, what is the return in each stock? So you have to find the return for each stock. And what is the third one? What is the covariance of a stock R and S? So also you have to find out the covariance of stock R and S. Then determine the correlation coefficient of stock R and stock S. Next one is, what is the portfolio risk of a portfolio consisting of 40% and 40% R and 60% S. So here you have to find the first question, expected return is given. You have to find out the expected return on a portfolio consisting of 40% R and 60% S. Here in the last question, portfolio risk you have to find out for portfolio consisting of 40% R and 60% S. So these are the questions asked in this particular question. Under main question, these are the sub questions you have, and one more question is there, that is see here, B part. Consider the security T along with the stocks R and S. So here two stocks are R and S. So one more security, we are dealing with the problems of three securities. So again one more security is added. So you have to consider the security T along with these two stocks given R and S, and its return over the last 2 years are 2013 it is 16% and 2014 it is 10%. So what is the expected return and risk of the portfolio consisting of equal investment? So you are asked to calculate the expected return and as well as risk, wherein it consists of equal proportions. So here is the solution for the problem. So under first one, you have to calculate the expected return. So calculation of expected return, you have to take these R and S values. Then first write this particular heading, that is R minus R bar, S minus S bar. Then go for R minus R bar the whole square, S minus S bar the whole square. So here first find out the R minus R bar. For that return for R we know. We have to find out the R bar. So R bar is nothing but it is summation of R by N. So summation of R value is add the two of the values for 2 years. So then you are going to get it as 26. 26 by n is 2, number of years 2. So that comes to 13. Then same way you have to find out the s bar, that is summation s by n, that is equal to summation s is 30 upon 2, that comes to 15. So here we got the values of r bar and s bar. Now you have to subtract the r bar from r. So r minus r bar, that is 10 minus 13, that comes to minus 3. Then for s it is 12 minus 15, that is minus 3. Then 2014 for r, 16 minus 13, that is equals to 3. For s, 18 minus 15, that is equals to 3. So hope you have understood this, how we have got r bar values and s bar values, then how we have deducted the values from the r. So you have found out the r minus r bar, s minus s bar. Now the thing is you have to square it. So that is minus 3 the whole square, again minus 3 the whole square, that comes 9. Same way 3 the whole square here 9, again 3 the whole square, it is 9. So now just add these values and keep. Then find out the standard deviation. So standard deviation is equals to root of summation r minus r bar the whole square upon n. So this is the formula for the standard deviation. Some root of summation r minus r bar the whole square upon n. So here what is the r minus r bar the whole square upon r minus r bar the whole square? We have got the summation, that is for 2 years. So that value is 18. So root of 18 upon 2, that comes to root of 9, square root of 9, that is square root of 9 is nothing but it is 3. So same way find out the standard deviation s, that is equals to, for s it is summation of s minus s bar the whole square upon n. So that is summation of s minus s bar the whole square is 18. So root of 18 by 2, that is equals to root 9, that comes to 3. So next question is you have to find out the what is the expected return on a portfolio. Here now you have to calculate the return on you have to take the values as 40% R and 60% R. So as you have already found out there the R bar and return on R and return on S. Now the thing is you have to find out the return of portfolio. So that is the summation of R and weight of R plus R bar S into weight of S. So weights here are nothing but you can take it as W or X. So any letter you can use. Relevant letter should be used, either X or W. So return on portfolio formula is summation of return of that particular stock, first stock, how many stocks given, those much of stocks you have to take one by one. Summation means you have to add all the stocks, that means summation of first stock into weight of that first stock, then summation of second stock with second weight of the second stock. So likewise, so whatever stocks, number of stocks are given, those should be added. Summation is nothing but adding those stocks with their relevant weights. So here just substitute the values. So R bar, R, for R stock we have found out the R bar, that is nothing but summation, that value is 13 into weight. Here it is given in the question, first question, that is you have to take 40% of R and 60% of S. So that's why we have taken it as 0.4, that is 40 by 100 is 0.4 plus 15 for S stock into, it is 60%, that is 60 by 100 is 0.6. So if you do the calculation here, you are going to get it as 14.2 percentage. Okay, so this is about the first question, solution for the first one. Then second one, you have what is the return in each stock. So return only we have calculated, this is second one, no? Here this is the second one, calculation of return on portfolio with 40% and 60% of R and S stocks. Next, coming to the next one, calculation of variance of stock R and S. So you have to give the formula here. Covariance RS is equals to 1 by N into summation R minus R bar into S minus S bar. So this is the formula for covariance. That comes like you have to take the 2 years values here. So 2000 for 2013 it is R minus R bar we have found out, and S minus S bar already we have found out in the previous slides. So there minus 3 into minus 3, that comes to 9. Same way for 2014 it is 3 into minus 3, that comes to 9 here. Minus 3, it is 3 into 3 for 2014. So it is total is 18. So 1 by n into, directly you can do it as into 18. So 1 by 2 into 18 is nothing but it is 9. Next question, you have to find out the correlation coefficient of stock R and S. So again apply the formula, coefficient of correlation coefficient or coefficient of correlation of stocks. You have the formula R is equals to covariance upon standard deviation R into standard deviation S. You have to be thorough with these formulas of covariance and correlation coefficient, as well as expected return of portfolio, risk of the portfolio. So if you practice, if you do these problems more times, then it is very easy to do. So here we have the formula, that is R is equals to R for both the stocks R and S is equals to covariance upon standard deviation R into standard deviation S, that comes to, so covariance value we have found out, that is 9. So standard deviation R, standard deviation S already we have found out in the previous slide. So that particular value should be given, that is 3 into 3, that comes to 9. So 9 by 9 is equals to 1. So correlation coefficient is 1. So next one we have is, you have to find out the portfolio risk for consisting of 40% for R stock and 60% S. So put the formula. Again, I am not going to read the entire formula here. You have the formula here, just to substitute the values. So X R square, that is weight of the stock R, you have to take 0.4, 40%, no? So 40% means 0.4 the whole square into standard deviation r square, that is 3 the whole square, plus weight of stock S, that is 60%, 0.6 the whole square into standard deviation is 3 the whole square, plus 2 into X, weights of both the stocks. So if you are feeling it difficult here, X and X, if you are not familiar with these X alphabets, you can take W also, weights, it is relevant, W or WS. If you are getting confused, then you can use W also. Okay, so 2 into 0.4, again 40% of weightage for R and 60% of weightage for S. Then standard deviation R into standard deviation S, that is 3 into 3 into correlation coefficient. In the previous slide we have found out that it is 1. So substitute all these values and find out the, do the calculation, then you are going to get it as 3%. So this particular A part is completed. Then we have B part here, B question. That is, you have to consider the security T along with the stock R and S and its return over the last 2 years, where the values are given 2013, 2014, we have been given the values, that is 16% and 10%. So you have to find out the expected return as well as risk of portfolio, taking equal proportions. So here same way you have to take 2 years, then for a T, stock T, whatever values are given, take those, then T minus T the T bar and T minus T bar the whole square. So as we have done previously, the same way you have to find out. Here T minus T bar, that is nothing but 16 minus T bar is equals to, find out the T bar first of all. So T bar is equals to summation T by N, that is equals to summation T is, it is 26, 26 upon 2, that comes to 13. So here T minus T bar is 16 minus 13, that comes to 3. Then 10 minus 13, that comes to minus 3. So make the values of T as a whole square, that is 3 whole square, again minus 3 the whole square. So both will come as 9. So summation is 18. So here find out the standard deviation also, because it is asked in the question. So you have to find out the risk also. So standard deviation is equals to, put the formula, standard deviation or sigma T is equals to root of summation T minus T bar the whole square upon N, that comes to root of 18. T minus T bar the whole square is 18 by 2, that is equals to 3. So now find out the expected return on portfolio. So put the formula, return on portfolio is equals to R bar R into XR plus R bar S into XS plus R bar T into XT. Here we are considering the 3 securities. So additionally we are given, first we have been given only 2 stocks information. Then in the next part, in the B part, we have been asked to add the T stock, T security. So we have calculated the risk of that particular security and we are finding the expected return of 3 securities. So here substitute the values. So R bar R is nothing but it is 13 into weight of R, that is here you have to take it as in equal proportions. So if you take 100%, then it is, if for 3 it is 0.33, 0.33, then 0.34. Okay, so based on that, we are dividing the proportions for 3 securities. Plus R bar S is, what is the value for S stock is 15, then into 0.33, again plus 13 for T security into 0.34. So that comes to 16.63%. So we have found out the portfolio return. Now the next one is you have to find out the portfolio risk. So put the same formula again for 3 securities. I have told you that you have to take the, so once for 2 to 3 times if you are writing this formula, then it becomes very easy. It's only in understanding that this particular formula, it it is big to see. It is you may feel that it is very big and how can I remember, but while doing it is very easy if you understand the formula here, concept here. So standard deviation P is equals to square root of, root is for whole root, so root of, so these covariance, you have to take a correlation relationship between all the securities. So this formula comes, that is x for R standard weight into standard deviation, again weight into standard deviation for another stock, weight into standard deviation for third stock, 3 stocks weights and standard deviation, plus 2 into XR XS or WR WS. Then weight you have to take for both the stocks and standard deviation for both, and coefficient correlation. So if you understand this, then you can go for another stock, and same way you can do it for another stock also, that is for stock R S, then S T and R T. Okay, so in this way you have to, you are giving the relationship, you are finding out the relationship of all the stocks, of all the given stocks. So here we have 3 stocks, so the relationship between 3 stocks are being taken in Markowitz model. So here substitute the values, so that is whole values, just whatever values we have got for R and the standard deviation values, S and the standard deviation value for S, and T and standard deviation value for T security, then 2 into, so you have to carefully put these values. So even one is, if you are misplacing or doing the calculation wrong, the whole thing will go wrong. So just see the values, whatever you have calculated in the previous slide, those values I have put here. So here you are going to get the value as root of 0.9216, that is 0.96%. So here covariance for so in the previous slide I have I have not given this for ST and RT, we have not found out. So for ST and RT, coefficient of correlation, that is covariance, you have to find out. First you have to find out the covariance, then correlation coefficient. Because the correlation coefficient is nothing but it is covariance upon standard deviation S into standard deviation T. Standard deviations, isn't it? For that you have covariances. For that you have to find out the covariance first. So covariance of stock S and T is equals to 1 by N summation S minus S bar into T minus T bar. Then same for R and T, you have to take this formula and substitute the values. So wherein for stocks S and T, correlation coefficient should be found, and for R and T also you have to find out the correlation coefficient. So base, after doing these calculations only, you can substitute those values here, like coefficient correlation of R and S, then correlation coefficient of S and T, and coefficient correlation for R and T stocks. So based on these values, if you substitute these values, then you are going to get portfolio risk.